In the dark silence of ancient oceans, long before humans ever imagined fear, something drifted through the water that should not have worked, should not have survived, and should not have existed at all, yet it did, and it may be one of the most disturbing designs evolution ever produced, a predator so strange that for over a century scientists couldn't even agree where its weapon belonged on its body, a creature known as Helicoprion. And if you think modern sharks are terrifying, you haven't met the one that carried a rotating spiral of teeth like a living circular saw hidden inside its mouth. Imagine diving into an ocean 270 million years ago during the late Permian period, where reefs were crowded with armored fish, trilobite remnants still lingered in the evolutionary background, and massive marine reptiles had not yet taken control, but something far more alien was already cutting through the water column. Not with the sleek symmetry of a great white shark, but with a jaw system so bizarre it defies instinctive understanding, because instead of rows of teeth like modern sharks, Helicoprion had a tightly coiled spiral of hundreds of teeth stacked in a continuous helix, growing outward like a biological weapon that never stopped expanding, and every new tooth pushed older ones forward in a rotating mechanism that scientists still struggle to fully reconstruct with certainty. But what we do know is enough to unsettle even the most hardened paleontologist. Early fossil discoveries of this creature did not reveal a skull, a skeleton, or even a clear body outline, only a strange spiral structure that looked more like a broken seashell or a piece of ancient machinery than anything once alive. And for decades it was misidentified, misplaced, and misunderstood, placed in categories ranging from ammonites to strange mollusks, until deeper anatomical analysis revealed the horrifying truth. This was not a shell, it was a jaw, a lower jaw embedded with teeth, arranged in a perfect, curling whorl, and somewhere inside the mouth of this shark-like predator, that spiral was alive, rotating through growth like a conveyor belt of bone and enamel. To understand how terrifying this is, you have to break your modern assumptions about predators, because sharks today replace teeth in neat rows, shedding and regenerating like organized weapon racks. But Helicoprion didn't replace its teeth in linear order. It stacked them forward into a spiral coil that likely sat deep inside the throat or lower jaw, meaning every bite it took wasn't just a snap, it was a mechanical feeding event where prey could be dragged deeper into a rotating forest of serrated blades. Scientists still debate exactly how this structure functioned, but one dominant theory suggests that as Helicoprion closed its jaws, the spiral teeth would have acted like a circular slicing mechanism, pulling soft-bodied prey inward while shredding it simultaneously, meaning escape was not just unlikely, it was mechanically impossible once contact was made, and this raises an unsettling question: what kind of evolutionary pressure creates something like this? The Permian oceans were not gentle places. They were battlegrounds of survival where oxygen levels fluctuated, ecosystems were unstable, and competition for food was extreme, so extreme that nature seemed to experiment freely with body plans that would later vanish forever, and Helicoprion may represent one of its most radical experiments, a cartilaginous fish related to early sharks and ratfish, belonging to the broader group of chondrichthyans, yet diverging so dramatically that it feels almost alien in comparison. The first reconstructions imagined this spiral tooth while protruding from the front of the snout like a buzz saw, an image so horrifying it became iconic in paleontological imagination, but later fossil evidence suggested it was actually embedded deeper in the lower jaw, hidden until the moment of feeding, meaning prey likely never saw the weapon that killed them until it was already too late. And perhaps the most disturbing part is not just the structure itself, but the fact that it worked well enough for Helicoprion to exist for millions of years, surviving multiple environmental shifts before finally disappearing in one of Earth's great extinction events. Even today, when scientists reconstruct its anatomy using CT scans and comparative anatomy with modern relatives like ratfish, they still argue about its head shape, its feeding posture, and even how wide its mouth could open. Because every answer seems to reveal another contradiction, another impossibility hidden inside its design, as if evolution briefly stepped outside the rules and then quietly erased the evidence. And yet the spiral tooth whorl remains, frozen in stone, a perfect coil of biological engineering that feels more like a warning than a relic, because it forces us to confront a deeper truth about prehistoric life. The ocean was not just a place of survival. It was a laboratory of extreme experimentation, where predators didn't just evolve to hunt efficiently, they evolved to hunt in ways that challenge our very understanding of what a predator should be, and somewhere in that ancient darkness, Helicoprion was not just swimming, it was testing the limits of what a jaw could become, what a bite could do, and what nature was willing to create when there were no rules yet written. And if part 1 revealed the nightmare silhouette of Helicoprion's spiral weapon, then what lies beneath that image is even more unsettling, because the real mystery is not just what this creature looked like, but how it lived with something so mechanically complex inside its body, functioning not as a static structure but as a growing, shifting biological mechanism that had to feed, survive, and adapt in a world where failure meant instant disappearance from the fossil record. To understand this, scientists had to rebuild Helicoprion almost like forensic engineers reconstructing a machine from a single surviving gear, because unlike dinosaurs with complete skeletons, Helicoprion left behind almost nothing except those spiral tooth whorls, and yet those fragments tell a story of a predator that may have been around 8 to 10 feet long, possibly larger in some species, with a cartilaginous body similar to modern sharks but more primitive in structure, meaning its skeleton was light, flexible, and almost entirely unossified, leaving very little chance of fossilization except for its teeth, which were mineralized enough to survive deep time. And inside that fragile body was the true engine of horror, the whorl itself, a continuous growth system where new teeth formed at the back and were pushed forward in a spiral, stacking tightly like layers of rotating blades. And this is where the biology becomes truly strange, because unlike normal sharks where teeth are replaced and dropped, Helicoprion appears to have retained every tooth it ever grew, meaning its feeding apparatus didn't reset, it accumulated, becoming more complex with age rather than simpler, turning its mouth into an ever-expanding archive of past bites. And when scientists simulate how such a structure would behave, they begin to see a feeding motion that is less like a bite and more like a pulling and slicing mechanism, where prey, likely soft-bodied animals such as ancient cephalopods, smaller fish, or primitive marine creatures, would be seized and drawn inward, not crushed instantly like in modern great whites, but processed through a moving spiral of enamel, each tooth guiding the prey deeper into the throat while simultaneously tearing it apart, almost like a conveyor system designed for destruction rather than digestion. But even this explanation struggles to fully capture the mechanical paradox, because the spiral is not just functional, it is spatially disruptive, meaning it would have occupied a significant portion of the lower jaw area, raising questions about how the skull supported it, how muscles attached to it, and how the animal prevented self-injury during feeding, since a rotating or sliding mass of teeth inside a confined jaw creates risks that modern biology simply does not replicate. And this is where Helicoprion begins to feel less like a shark and more like a failed prototype from evolution's experimental phase, a design that somehow worked well enough to persist but was never repeated again in any known lineage. The Permian seas themselves help explain why such extremes could exist, because this was a time of unstable ecosystems, where oxygen levels in the oceans were inconsistent, food chains were still reorganizing after earlier mass extinctions, and competition between early fish groups and cartilaginous predators was intense, forcing rapid innovation in hunting strategies. And in that pressure cooker of survival, Helicoprion may have evolved its spiral jaw not as a perfect solution, but as a desperate one, an adaptation that exploited a niche no other predator had claimed. And yet, despite its strangeness, there is evidence that it was not a slow or clumsy hunter, because its body proportions suggest a streamlined swimmer capable of moving efficiently through open water, meaning it likely operated not as an ambush predator hiding in reefs, but as a roaming midwater hunter, scanning ancient oceans for vulnerable prey, and when it struck, the encounter would have been swift and devastating, with little chance for escape once the spiral engaged. What makes this even more fascinating is that modern reconstructions of Helicoprion's head have changed dramatically over time, shifting from the infamous buzzsaw face theory, where the spiral was placed at the front like a chainsaw protruding from its snout, to more anatomically grounded models that place the whorl deep inside the lower jaw, almost hidden, suggesting that the true horror was not visual spectacle but functional invisibility, a weapon that prey could not see until it was already being processed. And this invisibility adds a psychological dimension to its predation, because in modern oceans, many predators rely on speed, stealth, or brute force, but Helicoprion may have relied on something even more unsettling, inevitability. A feeding system that once initiated could not be reversed, where the spiral's geometry ensured that whatever entered its mouth was committed to a one-way journey. And still, despite all these reconstructions, uncertainty remains, because cartilage does not fossilize well, meaning the skull shape, jaw articulation, and muscle arrangement are still inferred rather than confirmed, leaving Helicoprion suspended in scientific ambiguity, half real and half reconstructed imagination, a ghost built from teeth alone. But even in that uncertainty, one truth remains stable: this was not a marginal predator, not a failed evolutionary curiosity, but a successful one that survived for millions of years, meaning its design, however alien it seems, worked within its world. And that realization is perhaps the most unsettling part of all, because it forces us to accept that the oceans of deep time were filled not just with familiar forms of life, but with entirely different solutions to survival, some of which look so strange from our modern perspective that they feel impossible, and yet they were real. They breathed, they hunted, and in the case of Helicoprion, they carried inside their bodies a spiral of teeth that turned feeding into something closer to mechanical inevitability than biological behavior. And if the spiral jaw of Helicoprion feels like the peak of evolutionary strangeness, the final piece of its story is not about what it was, but why it vanished. Because no matter how efficient or horrifying a predator becomes, the ocean does not preserve perfection, it only preserves what survives the next collapse. And Helicoprion lived in a world that was about to end in one of the most devastating mass extinctions in Earth's history. The Permian-Triassic extinction event, often called the Great Dying, where up to 90% of marine species disappeared in a geological blink, reshaping life on Earth so completely that entire ecosystems were erased and rebuilt from near zero. And in that catastrophic reset, specialized predators like Helicoprion may have become too narrowly adapted to persist, their evolutionary advantages turning into vulnerabilities as food chains collapsed and ocean chemistry shifted dramatically. Imagine an ocean where oxygen levels drop, temperatures rise, and the delicate balance of marine life destabilizes so violently that the prey Helicoprion depended on simply vanishes, because a weapon is only as effective as the world it hunts in, and when that world disappears, even the most perfect killing machine becomes irrelevant. And yet, Helicoprion did not vanish without leaving behind a legacy of confusion, because for over a century after its discovery, scientists struggled to even place it correctly on the tree of life, debating whether it was a shark, a relative of chimeras, or something entirely separate within early cartilaginous fish evolution. And it is only through modern techniques like CT scanning, 3D reconstruction, and comparative anatomy with living relatives such as ratfish that we have begun to stabilize its identity as a member of the broader chondrichthyan lineage, a distant cousin to modern sharks rather than a direct ancestor. But even now, its exact feeding behavior remains partially speculative, because no living animal today carries anything remotely like its spiral tooth whorl, meaning there is no perfect modern analog to confirm our interpretations, leaving Helicoprion suspended in a space between certainty and reconstruction, where science fills the gaps with probability but never complete certainty. And this uncertainty is part of what makes it so powerful as a scientific symbol, because it reveals how much of Earth's history is still locked away in fragments, how entire body plans can exist, dominate for millions of years, and then vanish without leaving a clear explanation of how they functioned. When we look at the spiral today, often displayed as a fossilized coil of stone-like enamel, we are not just looking at a tooth structure, we are looking at a problem that evolution solved in a way we are still trying to decode, a reminder that intelligence and efficiency in nature do not always align with simplicity, and that survival does not always produce designs that make intuitive sense to us. And perhaps that is why Helicoprion continues to haunt scientific imagination, because it forces us to confront the idea that evolution is not guided by aesthetics or comfort, but by pressure, randomness, and deep time experimentation, where even the strangest forms can thrive if the environment allows it, no matter how alien they appear to future observers. In that sense, Helicoprion is not just a prehistoric shark-like predator, it is a message from a world that no longer exists, a world where the rules of marine life were still being rewritten, where extinction and innovation moved hand in hand, and where something as improbable as a rotating spiral of teeth could become a successful survival strategy. And as we step back from its fossilized remains, what remains is not just curiosity or horror, but a deeper reflection on the fragility of biological design. Because Helicoprion reminds us that dominance in nature is temporary, that even the most specialized predators are bound to the stability of their ecosystems, and that when those ecosystems collapse, even the most efficient killing structures become meaningless relics. In the end, the spiral is more than a jaw, more than a fossil, and more than a curiosity of paleontology. It is a frozen echo of experimentation on a planetary scale, a record of evolution pushing itself into extreme forms and then retreating, leaving behind only stone impressions and unanswered questions. And perhaps the most profound truth it offers is this: Earth has already produced life forms so strange that if they were alive today, we would struggle to believe they were real, and Helicoprion is one of those reminders, a silent spiral turning forever in stone, asking not to be feared, but to be understood as part of a vast, unfinished story of life itself.